morning, everyone. My name is Chris Posey. I'm the marketing manager at OGI Process Equipment. We're happy to have you here with us today. Today's focus is going to be on TERI heaters, and you're probably familiar with TERI heaters. TERI is known for its high-performing water bath heaters, but TERI produces other heaters and ancillary products you might not be aware of and that might be valuable in your application. Presenting today is OGI's Director of Technical Sales, Chance Borger. As we go through today's webinar, please feel free to post any questions or comments you might have over in the console on the right side of the screen. Toward the end of our webinar, Chance will answer your questions and address all comments. Before Chance gets started, I just wanted to talk a little bit about OGI. Now, OGI has been in business for about 31 years now. Again, you're probably familiar with the TERI brand. OGI also produces a direct contact heater called Quick Water, and we also produce the Total Arc Relighter. OGI is a certified women-owned company, and we are proud to be right here in Sand Springs, which is just outside of Tulsa, Oklahoma, which is where we've been since the company began. So with that, I'm going to go ahead and turn it over to Chance. And again, if you have questions or comments, just post those on the right side as we go through the webinar, and we'll address those at the end. Take it away, Chance.
All right. Thanks, Chris. I want to start a little bit by kind of walking you guys through our facility and capabilities if you're not familiar with us or our company. So, some of the things I like to highlight, most importantly is that everything we do at OGI starts here and ends here. So, from the first quote that you send us, we have a full engineering staff that will design and quote that for you. And then from there, we've got our own production facility where we design, build, test everything here on site. And even we will perform a FAT on it before it leaves. We've got a 50,000 square foot manufacturing facility. Several different things on site to help us through the manufacturing process. And then we also have a UL listed panel shop. So Chris mentioned the Total Arc Relighter, which is one of our patented products. But we also do many other different controls schemes for various things, which I'll address towards the end of the presentation. But all of that is done in our UL panel shop. So we were able to achieve that certification on all the panels leaving our facility. So with that, we'll get into a little bit the overview of this presentation. So from the title, more than just water bath, obviously we're going to be discussing some of the different types of heaters that we offer. We'll review the different products for the oil, gas, and pipeline industries that we offer, and then compare and contrast some of the heater capabilities, both for the water bath heaters and some of the other types of heaters we supply. And then we're also going to review some of our supporting products, such as controls and some things like that. So we'll review all those things here in this presentation. So I broke things down to kind of give us a better overview and able to compare and contrast a little easier. So we're going to start by going through our water bath heaters. So on the left here, you can see the types of water bath heaters that we offer. So we're going to start with the natural draft, which is our most basic. So that'll be our more than just that one, and we'll build from there. And then we're going to get into forced draft heaters, fuel gas heaters, vertical heaters, and then finally electric heaters. And then after we've had a chance to review those things, we're going to get into an additional type of heaters, and we're going to review vaporizers and glycol dehydrators. And granted, a vaporizer is somewhat of still a water bath, but it's performing a slightly different function. So that's why I've broken that into a second option, and then we'll end with supporting products. So the first thing I want to cover is, features that are going to be standard to all TERI heaters. So everything that leaves our facility is going to, adhere to these bullet points that I've highlighted here. For us, from an engineering standpoint, from a sales standpoint, in all of managed together, it's very important to follow all the codes that kind of that lead our industry. And so, most importantly, we're going to always be building in accordance to API 12K. And then along with that, you'll see ASME CSD-1 for all of our fuel trains. And then we're also going to be using NFPA 86 and 87 where applicable, applicable. Even though these are not, technically requirements, they're something that we'll often use based on the application or where the heater's going, or even if, the customer requests it. So, all that to be said is if there's any specifications that, you need to adhere to that you're not familiar with, that's where we can come in handy. We've got a lot of experience. We've been doing this for, like Chris mentioned, over 30 years. We've got a lot of experience here that can reference these specs and make sure the heater is meeting those and your controls are meeting those, and even help you outside of that with anything. So certainly, feel free to ask those questions to us when we're working on things together, and we're happy to help. One thing I like to also highlight is on our coils. The coil is one of the most important parts of the heater, of any of these heaters. And so that's why we take our inspection process very seriously on those. A lot of the times, we're really only required to follow the ASME standard, which is just to inspect one weld on the entire coil, and that approves it. But for us, we adhere to the 100% radiography on all process welds. So what that means is that every weld on the coil, we're inspecting the full circumference with an X-ray to make sure that there's no issues there. And we've got very good code welders here in our facility, and so they do a great job of, we rarely have to go back and fix anything, but if we ever did, it's going to get caught here rather than when it's too late. So with that, let's get into our first heater. So this is going to be kind of I'm telling you guys a lot of things you've already heard with this heater, but just want to set, like I said, that baseline to get us into the remainder of the heaters. So, the natural draft heater is going to be, just the most basic type of water bath heater. It's a straightforward design. It's going to be compatible with all different control schemes, whether if you want, if you just want a simple push button all the way up to a BMS or beyond that even. It can do all those things, but, it really just goes back to kind of what you're looking for. This is a heater that we use in a majority of our applications. Most of the time it's going to fit what you need it to do. There's, kind of certain cases when this doesn't become as attractive, or maybe it will get ruled out. And that's when we start to get into our other type of heaters, which we'll address and compare throughout this presentation. So this is available in 1 to 3 fire tubes. As you can see here, the reference picture that I've got is actually a dual fire tube. It's we kind of see those all over the place. More often than not, there's going to be a single fire tube because they're usually going to be handling a lower flow rate and pressure drop and things like that. But if we need to get more heat into the system, we can get up into those triple fire tube designs. The last thing I want to talk about is the second to last, excuse me, is the slipstream design. And this is something that I'll kind of address on how it can be used throughout different types of heaters, but the slipstream design is becoming a very, popular aspect of all of our water bath heaters, and it essentially is allowing us to use a smaller heater, or maybe less heaters if we're needing to do several heaters in parallel, but still get heat into your system. So essentially what we're doing is bypassing part of the coil, taking a superheated gas, well, excuse me, not superheated, but a hotter gas, and blending that with that cool gas to get to your process temp. So we're still able to avoid any effects from Joule-Thomson there, while still getting it into a smaller footprint. It seems from our perspective, there's getting less and less space, and but we're seeing more and more need for gas, and so things like this are becoming more popular. And so something that's definitely applicable for the natural draft heater, and other heaters as well. And finally, a good thing to remember, so with the natural draft heater, our max output is going to be 15 million BTU per hour. So that just kind of sets the limitation of what we can do there with a single heater. Granted, we can put, like I said, multiple in parallel, or even that's when the slipstream comes in if we need to get more heat into the system, but we've got that 15 million minimum requirement. So now we'll look into a forced draft heater. So this is kind of the next step from a natural draft heater, and this is going to be used in a situation where you might have a high flow application. So maybe there's more more flow coming in than we can handle with the natural draft heater, and you don't have the space for more heaters, or even if you do have multiple heaters on site, you still can't achieve quite the requirements that you need. So that's when we come to the forced draft heater. It does require more advanced controls. Typically, you can't really get away with just a relighter or a push button on these, because we've got a pretty advanced burner on this, as well as process controls that we need to be keeping an eye on and managing from a control standpoint. So you're typically going to see a BMS or maybe some type of custom controls on this. So that's something to keep in mind when you're looking for forced draft heaters. Another big advantage to them is that they can meet low NOx and ultra low NOx requirements. So more often than not, when we are selling these and the customer is using them, it's because they have some type of emissions requirement at their site. And so that's something we can meet with these heaters. They are a more efficient design. So with the natural draft heater, you're only about 68% efficiency. With a forced draft heater, you get up into the mid 70s on your efficiency. And so we get a lot better combustion by forcing that air into the heater rather than using a natural draft through like a flame arrestor. It's also available in 1 to 3 fire tubes, and we can also do the slipstream design with this heater as well. And finally, just addressing the burner. So if you notice on our last slide, and I'm sure you guys are all familiar with flame arrestors, we're just naturally pulling in that air. And then this is what we would be more dealing with a forced draft heater. We've actually got a burner and a blower. So like I said, getting a more efficient combustion into the system, which is actually what allows us to get a better overall output. So we're going to be over 15 million BTU per hour on this heater rather than under, like we would with the natural draft. So it's a very helpful feature when you're needing, like I said, more heat input into your system, or possibly need to meet higher conditions. So next we'll discuss the fuel gas heater. And for the most part, a fuel gas heater is not going to differ too much from a natural draft heater. From maybe in a non-educated person's view, it's just going to look just like a normal natural draft heater. The main difference is that we're going to have a wider or tighter gas temperature control ranges on the heater, because it's with these type of heaters and their applications, we're really just taking a natural draft heater and using it in a different application. So it's important that we have more control over the temperature output of the heater's gas. And so how do we achieve that? That's through the controls, which I've highlighted here. So that's what I was saying, if you just glance at this, like, oh, that's just a natural draft heater. But, maybe if you know a little bit more, you'll see, oh, this got, some different controls going on there. And so this specific one, you can see we've got a Honeywell BMS. That's what is highlighted here in the circle, along with the Total Arc, along with some of our TERI custom controls that we built in our panel shop. So that's kind of the difference that you would see on a fuel gas heater. We still can use a slipstream and even a tempering control configurations to make sure we're getting the proper gas temp. Also, if you're having sulfur problems, it's great for elemental sulfur control. And then with these heaters as well, oftentimes we will be superheating our gas to get to those higher levels. And this one, like I said, because we are at that lower kind of natural draft design, we are going to have a max output of only 15 million BTU per hour. All right, so next we'll discuss our vertical heaters. And this is another one that's actually becoming very popular as well, for multiple reasons, which we'll highlight here. But as you can see, it's definitely a different design. And the name's not very creative. We're just taking the horizontal heater and making it vertical. But from that, the internal designs of the heater does change quite a bit. So as you can see, we've got a little bit different design. So right here, this blue is going to be our burner. And we'll have multiple fire tubes here rather than just a single fire tube like we would on a horizontal heater exiting through our stack, and then our coil will come down around this fire tube so that we get the good heat transfer between the heated bath media and the coil. And through this design, we actually end up with a higher thermal efficiency than we would with the natural draft or forced draft heaters. And that mostly has to do with just that we're fighting less of the physics that you would be fighting with a horizontal heater. So that's why we see a better thermal efficiency on these horizontal heaters than the other ones. Another obvious feature, we're going to have a smaller footprint, which is what's making these more and more popular, especially if this is going to a residential area or near a residential area. These are a lot less noticeable than some of those big horizontal heaters. We've even done some of these that are actually enclosed in a building, and so it looks like just a building with a stack, and it's hardly noticeable outside of typical utilities you would see around the neighborhood. So these are very great design and good for those type of applications. Another thing I want to address is, we do have a quiet burner assembly on this one. So another reason it's going to be great for residential areas, it's going to be a lot quieter than some of our other heaters. And that's due to the type of design the burner is. And so this is going to be similar, I always compare it to like a turkey burner or something like that, where instead of just a single point of a flame like we would on a horizontal heater, we're going to have multiple nozzles here. So each nozzle you see here is going to be a different flame. And so that leads to an overall quieter, burner, which is where most of your noise is going to be coming from on these heaters. So that's a good benefit to these as well. The only limitation to these heaters is going to be the actual output itself. So looking at some of our other heaters, this one's only going to have an output of about 500,000 BTU per hour. So as far as output goes, it's going to be the lowest of our heater ranges. But for some of those residential applications and things like that, it's going to be a great fit because you're more often than not, you're not going to need those, but need that higher output, excuse me. But just something to keep in mind as you are, kind of planning out these different projects and things like that. So finally, we'll get into one of our newer products, which is an electric water bath heater. This is part of something that's come about as part of our ESG planning, and that's because it's going to be one of our lowest emission options, actually the lowest emission option, obviously. So, we're not going to be having any type of combustion with the heater. We're simply going to be relying on, electric coils to get the heat into the bath to transfer into the natural gas. So we've started, getting this more and more out there in areas that, maybe California, Oregon, places on the West Coast that might have, really tight regulations as far as emissions go. That's something we're pushing more and more into that area. So it's a really great option for that. This is going to have very minimal operational noise. I mean, basically nothing, because you have no burner again. Really nothing else going on. It's going to be, in most cases, as quiet as like a heater you'd have in your home or something like that. So it's a great option from that standpoint as well. And another thing is the max output is going to be about 1 megawatt, and that's just kind of where our design limitation is right now. Granted, you could put these also in parallel or series and kind of increase your heat from there. But that's something that is still kind of in the design phase with our R&D group. And just to give you some perspective on that, a 1 megawatt of electricity is about 3.4 million BTU per hour. So just kind of give you an idea of where we're falling on that line of other natural gas fired heaters. Certainly not bad, still better than the vertical heater, but it is a little lower than some of the other heaters. And so now that we've reviewed all those, I just wanted to take a second and kind of look through the comparison. So I chose a few different categories that, for me, when I may be talking with somebody who's not exactly sure what heater they want, these are some of the questions that I ask and is good to think about for you guys, or also ask to your customers when you're going through these. So the first thing is, low NOx capabilities. If there's any type of requirements, as far as their CO emissions or things like that, that's when you immediately want to go to a forced draft or electric. Obviously, as I mentioned, in most cases, you're going to end up at the forced draft just because of the output. If you remember, this is only about 3.4 million BTU per hour. So, In most cases, you're going to need a forced draft, which, we can get our emissions very low on that forced draft. It's, in most cases with the regulations that we see nowadays, we can satisfy any emission requirements. It's only in certain areas, like I said, and it might even be by, by local levels of their requirements that you might need to get into an electric heater. But for the most part, that forced draft is going to, kind of check that box on the low emissions requirements. If, for a reduced footprint, that's when we want to lean towards the vertical, obviously. Slipstream capable right now, the natural draft, forced draft, and fuel gas are our main players there. Those are heaters we're actively using at Zion on. I think there's definitely potential for the electric, but at this point, we're not quite there yet. And then for the max output, I just listed these here because I think that's a great reference. So natural draft and fuel gas both will be around 15 million BTU per hour, where the forced draft will be over that. So that's going to be if you've got some high capacity, high flow rates, big pressure drops, you're going to want to think forced draft. And then our vertical and electric heaters are going to be on the lower end of the max output for the heater. And so next we'll get into vaporizers. So these next two heaters, the vaporizers and the glycol dehydrators, again, are similar to at least the vaporizer similar to a water bath, but they're performing slightly different functions. So I've broken those out because of that. So looking at a vaporizer, it's going to be very similar to what you would see on a water bath heater. You're still going to have a single fire tube, a coil, bath media that all this is immersed in to transfer the heat. But the main difference is that our coil design and use is going to be much more important in the way that it's used rather than with our other natural gas heaters. So, with a natural gas heater, you can flow gas in either direction because we're just flowing vapor through there, right? There's no liquid or anything like that. But with a vaporizer, because we're flowing propane in there and the whole point is to vaporize it, it's very important that the direction of flow is maintained and used properly. So, if we were to flow propane into a vaporizer on this upper coil and try to flow down, we're going to be fighting gravity, and that, we're going to have a very poor heater, probably a heater that doesn't even function because our vapor is going to want to exit back this way. All of our liquid's going to want to settle down here, and we're essentially going to end up with liquid into our pipeline, which is the whole point of the vaporizer. So that's why it's very important that the direction is maintained and that we're flowing into the lower level so that vapor has a chance to separate from the liquid and rise up through the coil. So this is a picture of if you see an actual vaporizer in the field of kind of what it looked like. So, it does, from the exterior look a little bit different than what a typical water bath would look like. And these will also be typically forced draft. So just because of the heat required to separate the two phases of vapor and liquid, we do need a little bit more heat. So that's why we'll always usually rely on the forced draft rather than the natural draft. And the last thing, so the vaporizers do use a slightly different codes than some of the other water bath heaters. Granted, we're still going to be using API 12K, CSD-1, those type of things. But there's three other codes that we will be using, which are the DOT 192, NFPA 59, and NFP 58. So the NFPA 59 is going to be primarily used for utility companies that are buying these glycol dehydrators. So it's a code that applies to their usage and regulations when using the propane to supply to multiple users. So that's kind of the key word in that NFPA 59 is multiple users. NFPA 58 is going to be more for privately owned. So if you were a manufacturer or something like that, and you're just having this to use propane for your site, that NFPA 58 is going to be the code that's going to be applying to you. So you're not distributing this to multiple people or something like that. oddly enough, like a trailer park actually would fall under NFP 58. So even though they're privately owned and distributing to multiple people, they can still use that NFP 58 rather than NFP 59. So just some good codes to use and maybe refresh on if you're not familiar with them. But again, we've got the experts on that. So any questions, we're always happy to answer those, or presentations, whatever you might need. So I wanted to quickly compare a vaporizer versus a heater. So this is kind of the features that I've highlighted here are going to be essentially from a controls and burner perspective. So the first thing we'll look at is what do both of them have. Both heaters are going to have all of these low water, high water, low gas, high gas controls, as well as a water temp controller. And those are just essential safety functions to the heater, and something that we have to be keeping an eye on. And those are really all from a safety perspective. The one thing that a heater is going to have that a vaporizer won't have will be the process temp controller. And that's essentially only because of these last three items, which a vaporizer has and a heater does not. So if you think about the things that we talked about with a vaporizer, what we're doing is we're separating those two phases, the liquid and the gas. And so, we don't care so much with a vaporizer about process temp. What we really do care about is this liquid carryover here. So when that liquid carryover is happening, that means our heater is not functioning properly. And the two ways that we can monitor that is through a low water temp and minimum process temp. So if our bath temp is below its minimum design, or our process temp has dropped below its minimum design, we're most likely going to start having liquid carryover. So by monitoring these three things, we can actually keep an eye on the liquid carryover from the vaporizer to make sure that it's functioning properly. We're not getting liquid into the pipeline, and we're only getting vapor. These things don't matter on a normal natural gas heater, of course, because we shouldn't have liquid into that system. We're only worried about the vapor, so we don't need to monitor those things. So the last heater we'll talk about today is the glycol dehydrator. So this is something that is definitely not a water bath. It's got different features throughout it, and it's something that's used as part of a natural gas dehydration system. So the whole point is to, kind of like a vaporizer, remove water from the vapor, but with this function we're using natural gas instead of propane. So what we got here is a basic PNID of a glycol dehy. So what we got first is we'll have our gas and our glycol coming into this absorber here, and the whole point of this is just to get that triethylene glycol, which is what's going to be used in a glycol dehydrator, to absorb with the gas. So glycol by its nature is very attracted to water. So just by getting those in the same system, obviously there's more going in there than just mixing it in. That's got some different things to kind of slow down the speed, kind of like packing, that essentially just slowing down the velocity of the two fluids, fluid and vapor, as they mix. So we're going to mix things there, and once those two have been mixed, we're then going to move out to the so coming out of our absorber, we'll go up to our still column of our reboiler. From here, we'll separate out any water, vapor, or stripping gas, and then that'll go into a flash tank. From that flash tank, will actually flow through a filter, through this exchanger, and then up back into the reboiler. So once we get into the reboiler, that's where the separation starts to happen. So if you think about the dehydrator, what are we doing with it? We're dehydrating the gas, so we're wanting to remove the water from the gas. And so what happens in this reboiler is that those will typically be run between 212 and 404 degrees. And the reason, because we're trying to boil out water, of course. So anything over 212, we're going to start removing any type of water, distilling that away, getting that out of our system, and seeing it exit up through here as water vapor. And what we're left with is we'll settle out into this tank as the glycol and gas. So at this point, we should just have triethylene glycol and gas together. And then from that, we'll go into this glycol pump, back through the lean rich exchanger, and through here. So at this point, into the gas glycol cooler. We'll have our dry gas that's been processed exiting out through the top, and then our glycol will be going back into the system to go back through the whole process again. So when you've got a good good filter here and you're maintaining your system, sorry, I just gotta, I don't think my screen is caught up. All right, are we on the glycol dehydrator now? Is that? Let me know if you guys can't see that. So, so sorry if you guys didn't see any of that. But, anyways, once we get back through there, so Chris, can you see it? Okay.
It looks like for me, it's still on vaporizer versus heater. If anybody in the audience is able to comment on that, maybe it's just my screen. I haven't seen the glycol dehydrator slides yet. Ultimately, if we have to move on, we will have this presentation available for download, and so those slides will be available if this little glitch doesn't work itself out.
Okay. Well, I'll just keep moving forward. So overall, multiple stages of removal with the glycol dehy, and it's all contained in one skid. So even though it's a fairly overwhelming P&ID, this it's ultimately going to be contained into a pretty consolidated skid. So all those things we just discussed are all right here. So this is one of ours that we've done in the past. So it's a fairly compact system, but going to be based off many of the design principles that we're already using. Okay, so last slide that we have here, and then we'll address some questions. So just a few of our complementary products. So as I discussed, we do have the UL listed panel shop. So our two patented controllers are the Total Arc Relighter and BMS, and so we sell a lot of those, especially the relighters. They're very popular. They're very simple designs, and that was done on purpose. A lot of the field guys don't want multiple push buttons and PLCs. They just want simple designs, and so that's why we made these simple. You can see the relighter right here. It's just a switch and an indicator light and a button to light it. And all of your instructions are actually on the face, and the same goes with the BMS. We've got an additional switch in that case, but it's still simple for the most part. On top of that, we also do custom controls since we do have our UO panel shop. We've done a number of things. We've done carbon monoxide monitoring systems for plants. We're also starting doing custom controls for catalytic heaters. So, if you want more controls for your catalytic heaters rather than just having those, kind of an on-off function, we can actually provide controls to you that will allow those catalytic heaters to move in, based on the temperature. The last thing I want to address is our different type of skids that we offer. So we do offer fuel gas skids, metering skids, and regulation skids. So this came as something that we saw as a very important thing that's going to be going with most of the heaters that we're already selling into the industry. And then on top of that, we're essentially already experts in this field because a lot of our heaters are going to have the fuel trains that are going to be very similar designs and design principles to a lot of these skids. And so we saw this as a necessary product to start bringing to our customers and something that we can provide as part of our heaters. So we can sell you a fully functioning heater and skid together that you can essentially have a plug and play application. So definitely something that we're excited to be doing, and if you guys have opportunities, we'd love to talk to you more about those and some of the advantages that you have by going with your skids through us. So that is all I've got. So thank you all for your time, and I'll take this time now to address some questions.
All right, thanks, Chance. I'll review this webinar after we get done here and see if maybe it's presenting differently for the broader audience. And again, if the slides are stuck on vaporizer versus heater the way it is on my screen, we'll make the full presentation available to everyone. So it looks like we have one question, Chance, from John. Does the slipstream feature use a bypass throttling valve to blend the hot gas from the heater with lower temperature process gas?
Yes, yeah, it's a good question, John. It does. So you'll essentially see the outlet coil and the inlet coil connected together through kind of a U shape, and that will be met at a valve, and so that valve will be used as the throttling valve so that we can blend those hot and cool gases together. So yep, you're exactly right, that is going to be used.
All right, thanks, John. If anybody else has questions, you can post those quickly over the next couple of minutes as we wrap up here. I do want to mention that today's webinar will be available to stream later today from the OGI website. Just go to ogipe.com and click Media. There you'll find our entire library of webinars, today's, as well as the 18 previous that we've done. You'll also find a library of videos there, some documentation, and our social media channels. And speaking of social media channels, we hope that you will follow us on social media, on Facebook, Instagram, and LinkedIn. In doing so, you'll get regular updates on the goings-on here at OGI. Next month, our webinar will be entitled Applications for Total Arc Thermostatic Pilots. That webinar is going to air on March 15th. That's a Wednesday at 10 o'clock, just like today. So we hope that you'll join us for that. I think you'll probably see some, at least some connection between that webinar and this webinar. I'm not seeing any more questions, so I think we'll go ahead and wrap up. Thank you for joining us today, and Chance, thank you for presenting today. If any of you have any questions, if something comes up after we're finished here, you can always email us at sales@ogipe.com, and we will be happy to answer your questions. So again, thank you for joining us today, and we look forward to seeing you next month.
Thanks.